So in this video we're going to derive the quantile function for the exponential distribution. Now the first thing you need to try and calculate that is the cumulative distribution function. So we need the CDF of this function here, the exponential distribution. Now in the previous video we calculated what the CDF was, and what that gave us was it's 1 minus e to the negative lambda x. And on that distribution, lambda is greater than 0 and x is also greater than 0. So the quantile function is sometimes called the inverse CDF. So what we do is we try and put some different parameters in here and then solve for our quantile. Now what we're looking for is our quantile function, which you can use terminology of q to the a. So a is our quantile. So a is in 0 to 1. So that's our range for a. So for example, if you want our median, so the median, that's our middle quartile. So what we're looking for there is the q of 0.5. Now the interquartile range, so if we want to calculate that, that's q of 0.75, so that's our upper quartile, and we subtract it from q of 0.25, which is our lower quartile. But first of all, we need to try and find this function here, qa. So what we do is we just write down our CDF first. That's 1 minus e to the negative lambda x, and then we change our variables. So our CDF, we set that to a. So that's our parameter for our quantile. And then where we see the x, we put in qa. So 1 minus e to the negative lambda qa. And then what we want to do here now is try and solve this equation and get it in terms of qa. That's what we want. Okay, now to try and get this on its own, first of all, let's bring this exponential function to this side and send the a over to this side. So if you bring this all over here, so all of that, we'll end up with exponential function of negative lambda qa. So that's on that side. And then the 1 will stay here and then subtract a. So that's our first step. So we've got a negative sign in here. Now that is the same as writing 1 over the exponential function of lambda qa. So that's the same as that, and then this would just be the same as 1 minus a. These two equations are equivalent. So what we could do now is take the reciprocal to get this function on the top with the positive sign in the exponential, and take the reciprocal of this. So now we'll get e to the positive lambda qa equals 1 over 1 minus a. So that's fully legit there. And now if we take the log on both sides, we can try and get this qa from in here. So let's take the log of all of this equation. So now log of the exponential, they will just cancel out and we'll have lambda qa. So lambda qa, our quantile. And then we'll have the natural log of this function here. So the natural log of 1 over 1 minus a. Okay, well all that's left now is to get our quantile on its own, is to divide both sides by the parameter lambda. So now qa equals, I'll just call it 1 over lambda, natural log of 1 over 1 minus a. And that is our quantile function. So for example, if we wanted our median, so q of 0.5, let's write that here. Q 0.5, that's our median. What we would do is here now is where we see the a, we just plug in 0.5. So q of 0.5, that is 1 over lambda, natural log of 1 over 1 minus 0.5. So natural log of 1 over 1 minus 0.5, which is a half. Well, 1 minus a half is a half, so that just becomes log of 2. So then q of 0.5, so that's our median. That just becomes the natural log of 2 divided by whatever our parameter is of lambda. So that takes care of our quantile function for the exponential distribution, and there is an example. So the interquartile range, you could just plug in 0.75 and 0.25, and then the difference would give you your interquartile range. Okay.